Okay, this video is all about related rates. Okay, so related rates is an implicit differentiation problem because we are differentiating everything with respect to time. Okay, everything is related to time. And notice that t is not going to be a variable anywhere in your problems. So every time we take a derivative, no matter what the letter is, you are always going to have a d whatever dt, okay, or an x prime if we were talking about normal implicit, okay, a volume prime, a radius prime, a x prime, or a y prime, because all of these are derived with respect to time. Okay? So that's what this entire thing says here, but we're going to go with suppose y is equal to this nice quadratic equation. Okay? It says find dy dt, right? The derivative of y, the rate of change of y with respect to time. Okay? So in all related rates, they're all changing with respect to time when x equals 4, given that dx dt, right, the x value is changing with respect to time at a value of 2 when x equals 4. Okay, so they give you all this information that we're going to use once we take the derivative of our equation. Okay, so it's a first derivative with respect to time. So every time we take a derivative, we have a d whatever dt. Okay, that's what we need to remember. So the derivative of y, right, is just 1, but it's dy dt, or y prime. Okay, you can also use y prime, but it's always differentiated with respect to time. So then what's the derivative of 5x squared? 10x, but we also have this dx dt, right? We're taking the derivative of x with respect to time. So dx dt, or x prime, if you want to think about it like that. And what's the derivative of minus 6x? Well, minus 6 dx dt. Because every time we take a derivative of a variable, we always have the prime, the dx dt, dy dt, whatever. Okay? So it says find dy dt. Well, that's our variable. When dx dt is 2 and x equals 4. So we have everything that we need. Right? So 10 times x is 4, dx dt is 2, minus 6 times 2, dx dt is 2. Okay? So we're going to find the value of dy dt. What is the rate of change of y with respect to time? So 4 times 8 is 80. 6 times 2 is 12. 80 minus 2 is 68. So dy dt is 68 when x is 4 and dx dt is 2. Okay, now that was a pretty basic one without any context, right? So most of these related rate problems are word problems. And some type of a geometric something or other is doing something at some point. Okay, very descriptive words, I know. So a balloon is being filled at a rate of 10 pi cubic feet per second. And why not? Okay, so we're assuming this balloon is perfectly spherical, right? We also live in a very geometrically perfect world where all these things are perfect shapes and they rise and fall at perfect values. Okay, so this is a rate, right? Rate. What rate is that referring to? If the balloon is being inflated, what is changing about the balloon? It's volume, right? So this is a rate of change of volume, aka dv dt, right? the change of volumes rate with respect to time. So that's one of the things that we need to identify is what are our actual values mean. So 10 pi is the rate of change of our volume. And the question says, at what rate is the radius changing? So how do we write the rate of change of radius? That's dr dt, right? Rate of change. So that's our derivative of radius when the radius is 2 feet. Okay, and on the AP test, pretty much every time you need to have a geometric formula, they're going to give you the geometric formula. Unless it's a circle, they expect you to know pi r squared. Okay, they expect you to know a square is side squared. They expect you to know rectangle is length times width. But if it's one of these volume ones, they're going to tell you the formula. Okay, so we're going to take its derivative. So let's look at the left side. What's the derivative of a constant? Right, that's dv dt. The derivative of volume with respect to time. So v just becomes dv dt. Okay, and now on the right side, we have 4/3 pi. All of this is a constant. Remember, these are numbers. 4/3 pi is a constant. So we're basically going to apply the power rule. So let's multiply it by 3. What is 4/3 times 3? 4/3 times 3 is just 4. So this right side is going to simplify to 4 pi times r to the what power? Times r to the second. Okay, so that's applying the power rule. But now we have to include our derivative with respect to time, dr dt. Okay, we just took the derivative of r, so we have to have our dr dt, our derivative with respect to time. Okay, how does that feel right there? Okay, just like with implicit, anytime we take a derivative of a letter, we always have to have that with respect to time derivative. So dv dt, the rate of change of volume with respect to time, equals our formula derived times the derivative, the rate of change of radius with respect to time. Always have a d something dt. So now let's plug in our values. We know that the volume is changing at a rate of 10 pi. Right? We don't need to include units, of course. We'll think about that at the end. 10 pi is your rate of change of volume. Equals 4 pi. What was our radius?
2.
When radius is 2, so we know r is 2. And we're trying to find dr dt. So we need to solve this equation for dr dt. Okay, so algebraing this out, I have 10 pi equals 16 pi dr dt. So when we divide both sides by 16 pi, I can reduce my fraction to 5/8. Now this is the radius, right? This is the derivative of the radius. The rate of change of the radius has what for its units? If the volume was cubic feet per second, then our radius is single feet per second. So our radius is changing at 5/8 of a foot every second, right? Radius is a linear unit, so we're going to have a linear foot per second. If this were area, it would have been square feet per second, right? And volume is, of course, a cubic unit. So make sure we're watching our units when we do these problems. Okay, so that was a nice geometric one. Let's look at another geometric one. They're almost always geometry shapes. A ladder, 20 feet, 25 foot. A 25-foot ladder is leaning against a wall. The foot of the ladder is being pulled away from the bottom of the wall at a rate of 14 feet per second. Okay, well, let's come over here and label. Ladder, wall. let's call the vertical part, oh, I don't know, y. Or do you want to call it h? What do you want to call it? It really doesn't matter. Y? Okay, y is good, right? That's the vertical side. The vertical variable is always your y value. And then your horizontal is going to be x. Okay, the horizontal variable is always x. We're assuming that, of course, the ground and the wall are perpendicular to each other. Okay, we're not assuming this is on a hill or a slant. We're going to be perfectly perpendicular. Okay, so what's going on here? The being pulled away from the wall at a rate of 14 feet per second. So what variable is that we are given the rate of? If it's away from the wall, which is a horizontal thing, right? So this is dx dt. Dx dt is 14 feet per second. If the bottom is being pulled away, that means it's going this direction, right? And because the ladder is not changing, it's, right, this is still always going to be a 25-foot ladder. It doesn't change its length. What's going to happen to the top? The top is going to go down, right? So our height is going to be lower at the end, probably. Okay, let's see what it says. At what rate, so we're asked for a rate, is the top of the ladder moving down the wall, right? So we said our wall vertical is y. That means our rate we're solving for is dy dt, right? That's what we want to solve for. At what rate is the top of the ladder going down the wall? Okay, so I would not be surprised if we got a negative answer since the height is decreasing, right? You shouldn't be surprised either. But it's okay if you get a positive. It's just going down at a positive rate. Okay, so let's see what other information do we know. When the top of the ladder is 7 feet from the ground. Okay, so they're giving us a specific time where we want to see about the thing. So we know that the height is going to be 7. Okay, when the ladder is 7 feet from the ground, that's your vertical distance, is 7. Okay, what's our hypotenuse? 25, because that's the ladder, right? The ladder is still 25 feet long. So then how far away from the wall is our ladder when it has a height of 7? This would be whose theorem's problem? Pythagoras' theorem. 7 squared plus x squared equals 25 squared. And if you know your Pythagorean triples, this answer is automatically 24. A 7, 24, 25 triangle is a fairly familiar Pythagorean triple. So because we have a right triangle, this is actually a Pythagorean theorem derivation also. Okay, so we know that according to Pythagorean theorem, x squared plus y squared equals 25 squared. Right? Because we have to come up with a formula that relate x and y. And for a right triangle, this is your most basic formula that relate x and y. So let's take the derivative of this equation. What's the derivative of x squared? 2x. And we always have to remember the dx dt. We have to remember the rate with respect to time. Plus, the derivative of y squared is 2y times the derivative with respect to time, dy dt, equals 0, because that's the derivative of a constant. Okay, and what do we want to solve for? Dy dt. So let's get everything else on the other side. So let's subtract, right? Let's subtract this blue stuff. This will move over to there as a negative. And then we're going to divide by 2y. Okay, so yes, I'm going to do this all in my head. dy over dt is equal to, okay, we had our x, which was now just a 1x, so x dx dt, divided by y. Okay? So we subtracted the 2x dx dt, and then I divided it by 2, so 2 divided by 2 is 1, and I need to make sure that my x is negative, right? We're moving down, so it makes sense that our answer would be negative. So now let's plug in everything that we know. Our x value is that 24 from our Pythagorean theorem. Our dx dt was 14, all divided by our y value of 7, right? They told us the y value was 7. At what rate is the ladder moving down the wall when the top of the ladder is 7 feet? Okay, so we can do some simplifying. 14 divided by 7 is 2. 2 times negative 24 is negative 48, and our rate is feet per second. Right? We were given feet per second as our rates, so those are our units for rate. Right? It makes sense because the ladder is going down that we would have a negative rate as the answer. Right? The height is decreasing. In this case, pretty fast. You don't want to have your foot underneath that ladder. It might get smoshed. Okay, this is a pretty random one, but a fish is being reeled in at a rate of 2 feet per second. Okay, so it's a good thing that they drew fish down here, or else we wouldn't know where the fish is. From a bridge 16 feet above the water. Okay, so let's just draw. Let's assume, right, I don't like to do this, but we're assuming that the very tip of the rod is right there, so that we make a nice straight line from the top of our bridge down to the fish. Okay? So if a fish is being reeled in, what length is changing? Right? That is changing. The line that goes between the fishing pole and the fish is changing. So what kind of a triangle are we looking at here? Hopefully a right triangle. So what part of your triangle is moving? The hypotenuse, right? This is the d hypotenuse with respect to time, right? It's important to know where that part is going. The hypotenuse of that triangle is changing. Okay, so as the fish gets reeled in, right, this gets smaller and smaller and smaller because the length, like the fish isn't going directly. It's not flying out of the water straight towards the bridge. The fish is moving this way with the water, right, until, of course, it gets pulled vertically out of the water. But we're not assuming the fish is going directly along the hypotenuse. The fish is staying in the water and going horizontally. At what rate is the angle between the line and the water changing? At what rate is the angle? The angle, that's this, between the line and the water. This is what we're being asked to find. At what rate is the angle changing? So that would be d theta dt, right? The rate of change of your angle when there is 20 feet of line out. So 20 feet is the hypotenuse. Right, 20 feet is the hypotenuse of this triangle. Okay, so what is not changing?
The height.
16. The height above the water is not changing, right? So this is not changing. That's good. Our angle is changing. The hypotenuse is changing. So if we want theta, that means we have to use what type of an equation? What type of an equation have angles in them? Trigonometry. Trigonometry has angles in them. I don't know of any other thing that has angles. Trigonometry. We take the sine of an angle, we take the cosine of an angle, we take the tangent of an angle. So looking at our triangle, 20, of course, represents the hypotenuse. of our triangle. And what side does 16 represent? The opposite side. So if we have opposite and hypotenuse, which trig relates opposite and hypotenuse? The sine does. The sine does. The sine of our angle equals hypotenuse over opposite. And your hypotenuse is changing, so we'll just call that h, but your opposite is always 16. Your opposite is always 16. Okay, so I know this is a fraction, right? H over 16. So bear with me as I write this as 1 over 16 times h. Okay, h over 16 and 1 over 16h are mathematically equivalent. And I do that because now we're going to take a derivative. And my equation is sine of theta equals 1 over 16 times h. So what's the derivative of sine theta? Cosine theta times d theta dt. Right, we always have the rate of change of our variable. Theta is a variable with respect to time. Equals, on the right side, our constant is 1 over 16, and we're going to take the derivative of h with respect to time, which is dh dt. Okay? Sorry, Chihuahuas. This is opposite. This is all bad. So bad. Why do I even have a job? Well, that changes things, doesn't it? The derivative of 16 over h is a quotient rule derivative. So let's do the quotient rule. Low d high minus high d low. So low is h times the derivative of 16, which is 0, minus 16 times the derivative of h is dh dt, all divided by h squared. Okay, this simplifies to negative 16 dh dt. Do we know the change of the height?
2.
No. Oh, yes, it's 2. Derivative of the, sorry, h is hypotenuse, not the height. My brain. Derivative of the hypotenuse over the hypotenuse square. So hypotenuse was 20. When the hypotenuse is 20. H does not stand for height. It stands for hypotenuse. Brain. Okay. Those are all good. D theta dt, that's what we want to find. So what about this cosine theta business? Cosine is a ratio of the adjacent side to the hypotenuse. Okay? It's a ratio. We can figure this out. If I have a 16 as one side and a 20 as the other, I can find my missing side by using Pythagoras. 20 squared equals 16 squared plus x squared, since it's horizontal. And yes, this is in fact a 3, 4, 5 triangle. So it looks like our x is going to be 12. 12, 16, 20. Okay, so if my adjacent side is 12, cosine is adjacent over hypotenuse. Finally did it right. 12 over 20 reduces to 3 over 5. Right, they can divide them both by 4. So cosine is 3/5. Done. Now I have everything that I need in order to find for d theta dt. Okay, so 3/5 times d theta dt equals negative 32 over 400. I think my brain did that correctly right now because it wasn't working earlier. Let's multiply by 5/3, aka divide by 3/5. Okay. 400 divides by 5, and that gives me 80. Can anything else be reduced? 32 is not divisible by 3. So negative 32 divided by 200. I guess I could divide that by, I can divide it by 4. I can divide that by 8. So this reduces to negative 2 over 15. And my this must be, since it's a angle, radians per second. Okay? Because this is an angle, all of our angles are going to be in radians, not in degrees. So our angle is changing at a rate of 2/15 radians per second. Wowzers, that one was harder than my brain wanted it to be. All right, so related rates. Take the derivative with respect to time for every problem.